So my next project is going to be a quad with 5-inch props and 1407 motors. Originally I was going to use these 1407 motors, RCX 3200 kV, just because I already had them, and I thought, hey, a project which I can use old parts, use up some old parts. But no, saw these motors and couldn't resist. They I haven't flown them yet, but they appear to be a very good motor, much better than the RCX motor. Newer technology and stuff, like you've got arc magnets. One thing I noticed, actually I should say what they are. They are the 1407 3600 kV, so they're higher kV to start with. But they're both 1407. Can you see? This one's a bit taller, especially in the base, I've noticed, which I'm wondering if that helps with cooling, because by the time you put a flat carbon plate on the bottom there, this gap at the bottom is much bigger. So I'm wondering if that's a cooling thing. This one seems to be larger in diameter. I haven't got my calipers here, but I don't know if that's because of the magnets or whatever. But yeah, so in this video, what I'm going to be doing is thrust tests on a couple of props. 5-inch props, and we'll see how they compare, just for interest's sake, really. I think some people might be interested in that. It smells hot. It feels hot. Bloody hell. Now, at this point, I realized that 4S is not going to be good for static thrust tests. That motor is getting way too hot. I feel like in the air, it would unload fine, but this is another downfall of static thrust tests. The quad's not moving. The prop's not moving forward in the air, so it's going to get hotter and draw more current than it would in the air, and ultimately I'm not really sure if it's a good way of actually measuring the performance of a prop, I guess. So for all these tests, I've decided to go with 3-cell instead, just because it's going to be a good comparison between props and between the two motors, because I'm going to be running them both at 3-cell. So here we are with my Ghetto test stand, just some standard scales. I 3D printed this part just to raise the motor off here, just to make sure there's enough airflow getting to the prop, to make it a bit more accurate. Here we've got a Turnigy watt meter, I guess you'd call it. The main things I'm really looking for is the amp draw and the voltage. You can work out the wattage from that anyway. And obviously we've got our our thruster measurement here. Something else I want to note is when you're looking at my results, I think you can only really compare them to my results. I'm not sure if it's really fair to compare them to other people's results, just because so many different conditions, different setups, different thrust stands are going to be different. Some people use different, some people use power supplies instead of batteries, which is going to give an advantage. So yeah, something to keep in mind when you're comparing my results. Something else I need to mention about my tests is that I'm using an SN20A, and I can tell that I'm not hitting the ERPM limit, so that's not a factor. But modern ESCs are going to make more thrust than this. So that's another reason why you can't compare my results to other results, because they're going to be using different ESCs and you're going to get different numbers. For all my tests in this video, though, I'm using the same ESC. So, yeah. So the Brother Hobby is the clear winner here. It's obviously 3600 kV compared to 3200 kV. It's got stronger magnets, it's arc magnets. I don't know if there's something different with the windings, but it doesn't get hot like the RCX motor gets. So honestly, that's what I was expecting. That's why I bought these motors. Now, the interesting thing is how well the 5030 props do. They are the best performing props on both motors, and I think it's because the motors are so small, they can't really make static thrust on a high pitched prop. A high pitched prop will probably go faster in the air. I don't know for sure, but I suspect it would, because I don't think the RPMs will drop that much while you're in the air. But yeah, on a static thrust test, 5030s do really well, and I've found that in the past as well. So I'm going to be flying probably all these props just to test out on my quad, because it's going to be a very light quad, and it'll be interesting to see how it flies when it's unloaded in the air. But yeah, these are results. Yeah, take what you will from them. So I just wanted to make a note where I think maybe thrust tests might be a good indication of how the quad's going to perform is when you've got to like double back on yourself, when you kind of got to go, whew, and I'll put a bit of footage in right now so you can see what I mean. I think because your quad's almost stopped in the air and then you've got to start again from zero throttle, I think that's probably where a thrust test can tell you how well it's going to perform, maybe. But yeah, apart from that, I'm not going to take these thrust tests too seriously. I'm just going to put the props on this new quad and see how it feels really, and see which prop feels the best. So thanks for watching, and I'll see you next time.